and welcome to this video of limits at infinity. So first of all, what is a limit at infinity? Defining the limit of infinity in respect to the function. That's basically it. So infinity can be positive or negative. In this case, infinity can be represented both ways, as infinity alone or infinity with a plus or negative sign behind it. So we've got to understand that limits at infinity can be used and applied whenever you have some type of real-world application approach a steady state solution. So we need to know that the representation, the correct way of writing and working with limits to at infinity will be this one, in which you represent the limit and in the brackets all the function that we're going to be setting the limit for. So for the sole purpose of this video, I wanted to show you the three types of examples you're normally going to be getting when working with limits at infinity. So there's three types of examples from which we can work with some shortcuts and get an answer for our problem. Examples number one are those which the degree of the numerator is less than that of the denominator. Example number two include all of those which degrees in the numerator and denominator are equal or are the same. And the third type of examples are those which the degree of the numerator is greater than that of the denominator. So for example number one, in the first type of examples, we can see here that this is a division, obviously to compare and set a limit at infinity. We can see that on the numerator the highest degree is 2, and on the denominator the highest degree is 3. So in this case we're gonna circle both degrees, so we can see that the degree of the numerator is less than that of the denominator. So what we've got to know is that in every case you get this, which is the first type of examples, your answer is gonna be equal to 0. So let's move on. Okay, so after many tries, I really hope this doesn't stop. So for example, I apologize, I recorded the whole video without noticing until the end, so it stopped recording. For number two, the second type of examples is where the degree in the numerator and denominator are the same. In this example, 3x to the fifth plus 2x squared divided by 7x to the fifth minus 302x. We can notice that the degrees, the highest degrees on the bottom and the top are both 5. So knowing that and identifying that, we can then now start working directly with the leading coefficients, which in this case is a number next to the expression, the separate expression, this case being -3 and 7. That's always going to be your answer. So for the third type of problems, where the degree on the numerator is greater than that of the denominator, we can see this example. So for this example, we have x cubed minus 2x divided by 4x squared plus 1. We can see that the degree on the top is greater than the degree in the bottom, 3 versus 2. So the rule that applies to this automatically is always does not exist. And unless your teacher says it is okay for you to write this, or it's valid wherever, you can also represent it by, you can give the answer in positive infinite or negative infinite. So in conclusion, this topic, finding limits at infinite, is a very helpful and interesting tool we can use in our lives, actually, and it was discovered in the 17th century by kind of like three scientists, Newton, Einstein, and another one. I think it's a German one. So the way that, for an extra problem, and in case you're interested to know, we can use this in real life as in the following. Chemical reaction starts when two compounds forming anew over time. The amount of a new compound is the limit of a function as the time approaches infinity. So that's actually how you could apply it to your real life when making chemistry. That's all for today, and thank you.